Our stats final project was on spider gifts, and we chose to look at the before and after male weights of spiders.
So, for the background, we researched how male spiders give silk wrapped food to female spiders in order to convince them to mate. For example, the males may bring a freshly captured insect wrapped in their spider silk as a gift. The female determines that if the gift is good enough, the female spider allows the male to mate. The issue we investigated specifically was studying the relationship between the size of male spiders when they were eating two different diets. The high food diet consisted of 2 insects per week, while the low food diet consisted of 1 insect per week.
We investigated this issue using the data given, and we compared each diet, the low food and high food, and we examined the weight loss and weight gain for each spider that was a part of the experiment. And we used this data to determine if the diets worked efficiently and did as they advertised in terms of the final weight of the spiders.
Our research question for this data set was, is there a relationship showing a difference between the size of male spiders after the two different diets were implemented? We do not think there is a difference between the diets, because looking over the data, there was no significant pattern of weight gain or loss in LF or HF diets. Both had varying data that did not support what the diets advertised.
For example, there were spiders on the LF diet that gained up to 4 milligrams, and some that lost the same amount of weight. On the HF diet, some spiders lost 8 milligrams and some gained 5. We are comparing the LF and HF diets as our two groups using male mass before and after the trial to analyze results. Based on the data set, we do not need to subset.
The variables in this data set that we specifically used are shown as weights in milligrams. Each individual variable that we used is representing the weight of one male spider before or after the experiment using the diets that were performed. The variables are quantitative and they fit into the either before experiment weight or after experiment weight categories. And these variables are used to represent how weight affects silk production in terms of mating. And it's shown that overwhelmingly prey weight that will be wrapped in silk increased throughout the experiment. And in terms of creating new variables, we did not need to. The graph that we received from SAS was extensive and provided before and after variables for all the data points that we needed to cover. And on the next slide, we will include a graph and descriptive statistics of our data. Overall, this data is surprising based on what the two diets were advertising originally in terms of weight change. The mean of the high food weight change diet was much lower than of the low food diet, proving our hypothesis that there is no significance of the diets because of the results. The high food group had a larger sample size and a larger data range, while the low food diet had the opposite of both. The means of these data sets are close but not significantly, but their interquartile ranges are very similar values. These histograms shown above show that the distribution of the data varies greatly between the two data sets. In the high food, the distribution is more uniform in terms of having a clear mode, while the low food data does not show any significant curve or distribution shape. Overall, the two data sets show similar results in terms of interquartile range, but as for the distribution, significance of the results, sample sizes, and means, they vary greatly.
To answer our group's research question of, is there a relationship showing a difference in the size of male spiders after two different diets were implemented, we decided to use a t-test, specifically the two independent sample t-test, because it would allow us to accurately compare the means of the weight sizes for two independent groups compared to other t-tests like the pair t-test, which would only let us look at one group's means.
Our group used independent sample t-tests to examine whether the male spider weight after the experiment differed between high food HF or low food LF diet groups. The test compared the means of the two groups, assuming normality and equal variances, and also independent observations. And yes, our group explored whether diet affected other variables, such as amount of silk used to wrap gifts and the time elapsed before gift wrapping. These additional analyses helped us understand how food availability might influence deceptive behaviors in energy investment in mating displays.
A way this data set could be implemented into a real situation, this is an example we included, kind of a fun fact, is how when spiders get fat, they can have abdominal separation, difficulty molting, and can get injured by falling from high heights. They are also more of a target to predators and will be in higher danger due to not being able to escape as fast. When a spider is smaller or has lost weight from the experiment, they can become more agile, can find mates easier, navigate making silk strands easier, and can escape predators faster.
So we are 95% confident that the true difference in weight gain between the two spider diet groups lies between negative 2.1855 and 4.3442 milligrams. Because this interval includes 0, we do not have enough evidence to conclude that a real effect exists in the population. So our alternative hypothesis is HA equals the mean weight of male spiders on the LF diet minus mean weight of male spiders on the HF diet doesn't equal 0. And then null hypothesis is HO equals mean weight of male spiders on the LF diet minus mean weight of male spiders on the HF diet equals 0. And our test statistic was 0.68. Our P was 0.5038. And the p-value is 0.50 because this p-value is greater than 0.05. We fail to reject the null hypothesis. This means there is not enough evidence to support the alt hypothesis, and the u sub 1 minus u sub 2 equals 0 is considered the most reasonable conclusion based on the data.
In order to summarize our overall findings, we found that based on the fact that there's a large p-value and the confidence interval includes 0, there is not enough evidence to support the idea that weight varies when spiders eat different diets. And the p-value is a statistical measurement used in order to validate a hypothesis against observed data. A low p-value suggests that the observed effect is unlikely to have occurred by chance alone. This provides evidence that you reject the null hypothesis. A high p-value indicates that the observed effect is likely due to chance. This means the p-value gives us the information to fail to reject the null hypothesis.
So some possible ramifications. Our findings showed that the diet did not significantly affect the male spider weight, and that suggests that other factors could play a larger role in influencing the size and of the spider. And this highlights the complexity of mating strategies and indicates that environmental factors beyond diet should be explored in future studies.
In terms of limitations, this experiment we had limitations based on the way that the experiment was conducted by researchers. They only used 34 samples total, putting 10 on the low food diet and 24 on the high food diet. And this can not only skew the results, but not having enough data in general. But we also have inconsistent separation of the sample sizes, which can also be a limitation of clear data. Another limitation we had was with the results of the experiment. When it comes to the before and after weights of the spiders, there was at least one sample in each group in which we were given a before weight and no after weight was provided. So when finding and examining the data, these variables had to be ignored due to the fact that there is no final value given for them. Therefore, it doesn't explain any of the results of the experiment. And if we could have designed the data collection, we would definitely change a few things. There were so many variables involved in this experiment, including spider weight, the diet used, the prey weight before and after, silk production, and more. So we think that simplifying the experiment to focus on one question and yield one or at least a simplified result of the data would have made choosing a research question and examining the data much simpler. It's difficult to know exactly what the researchers were looking for when we look at this data because so many variables were involved. We could have examined any of these three major parts of the data set, so creating a generally clearer way of collecting data and why is what we would have changed.